What can the tornado in a bottle experiment teach us about flooding? Here's a fun activity for students. Take 2 large bottles, fill one with water, dry the edges, fit the second bottle on top, and then secure it with tape. Flip everything over, give it a spin, and ta-da! Tornado in a bottle. You get a nice visual funnel as it gradually flattens out. And once it drains, you can flip it over and do it again and again and again. So here's the question. With all that water pushing against the side, would it drain any quicker if I didn't add the swirl? Would it be a little faster or a lot faster? Let's find out. Let's start them both at the same time. Start the swirl and observe the results. So in the end, the water drained twice as fast by adding the swirl. And while that might seem odd and maybe a little counterintuitive, the key to understanding why is that we're not dealing with just one fluid here. We're actually dealing with 2. As the water from the top bottle flows down, so too is the air from the bottom bottle trying to flow up. Without the swirl, you create a traffic jam as the water and the air try to flow past each other at the opening. Each chug of water from the top bottle reduces the pressure above, and that allows a bubble of air to force its way past the water, equalizing the pressure and allowing more water to drain. If you watch closely, you can actually see the up and down pressure making the sides of the bottle move and flex. You can also see that same effect in the bubbles, as they shrink and grow along with the fluctuating pressure. Compare that to the tornado drainage, where the vortex of low pressure down the middle allows the air to get sucked into the top bottle and keep the pressure steady even as the water drains out. You can still see a little of that pulsing effect within the funnel, but it's much more subdued compared to the normal drainage. And while one simple fix for the air-water traffic jam in this particular case might be to add a hole at the top of the bottle, allowing the air to enter that way, what happens when you're dealing with a real-life situation, like a long pipe in the middle of a flood event? When it rains, runoff flows into catch basins and storm sewers and has to displace the air already in the pipes. If that same air-water traffic jam occurs here, the pipes can't carry the runoff as quickly or as high flows, and that can lead to flooding on the surface. One option that engineers have is to add manholes at regular intervals to release the air trapped in the pipes below during storm events as the flood flow moves through. But even then, we also need to be careful that the air displaced from the larger pipes or from the more intense rainfall resulting from climate change isn't so large that it launches the manhole cover lids into the air. Dealing with these challenges and these changing climate conditions requires a great deal of imagination and innovation from engineers. Simple experiments like these are a great way to share the engineering and science principles we use in our everyday careers. And if it gets people thinking about the interesting challenges we face, while also reminding us of the important concepts, well, it just might be the best way to keep those innovations flowing.